Good morning. Today our presentation is on portion size estimations. My name is Ashley Cobes.
My name is Bethany Foster.
My name is Hanyu Choi.
And I'm Devonna Dunes.
The research article that we choose to replicate for our project is improving accuracy of portion size estimation through a stimulus equivalence paradigm by Hausman colleagues 2014. This research study is targeted to the individuals who suffer from health issues caused by obesity or overconsumption of high-energy foods, such as Cheerios, crackers, and egg noodles, which were used in the intervention as target foods. The dependent variable in this study was the accuracy of portion size estimations made during baseline training, maintenance, and extension sessions. The dependent variable or the intervention used in this study is to teach 9 undergraduate students to identify and estimate appropriate portion size of foods. The goal is for the student to be able to identify the amount of food without using any tools such as kitchen scale, which is not very convenient to use when they eat outside of home. A non-concurrent multiple baseline design cross participants was used in this study to describe the experimental control. Here is the table 2, shows an overall summary of a percentage deviation data across the phases. And here's the table 3, shows the mean and standard deviation across phases. And here are the graphs for the study that shows all the subjects have improved in estimation of portion sizes during each phase. There are 2 participants' graph on the left, 174 and 178, were able to estimate accurately during the maintenance session, and another 2 participants' graphs also on the left, 201 and 178, they were able to correctly estimate accurately during the extension sessions. We found several literature review articles that support our project. The first article is Pediatric Overeating and Obesity by Miller and colleagues 2003. This is an article that will explain the background of what affects overeating in children and why it is important to address and treat the behavior. According to this article, the recent survey shows that the number of overweight children in the US has doubled within the 3 decades from age 12 to 19. Children with obesity are commonly associated with many health issues, such as high blood pressure, heart disease, diabetes, and so on. The article also described the factors that cause obesity in children. Food is one of the factors that increase childhood obesity. People eat out a lot nowadays, such as fast food, because it is convenient and inexpensive. Exercise is another factor. Children often engage in television, computers, and video games nowadays. Genetics is another factor for obese children who have family history of obesity, especially in their mothers. Children with obesity also take many consequences from both physical and psychological. Many obese children have type 2 diabetes, and they often described with negative terms like lazy or ugly by their peers. The article also mentioned some prevention strategies on how to avoid negative consequences, which is parental education early in their child's life is important. Also, to promote family sit-down meals and reduce the number of snacks will help. The second article is improving portion size estimation using equivalence-based instruction by Chu Xiu and colleagues 2015. The purpose of this study was to replicate Hausman's article in 2014 to evaluate the effects of EBI. They addressed the same issue. They used the same intervention to teach 3 graduate students to accurately estimate different portion size of foods. The result in this study shows that the intervention was effective on teaching individuals to estimate portion size accurately. The third article is conducted by the same researchers from the original study, Hausman 2014, teaching young children to make accurate portion size estimations using a stimulus equivalence paradigm, Hausman and colleagues 2016. But this study was conducted with much younger subjects, 7 children aged from 4 to 7 years, and they were taught to make accurate portion size estimations. The intervention and the materials in the study were used the same as the original study they conducted at 2014. Results in this study suggest that the intervention was effective and that 5 out of 7 children were able to make more accurate portion size estimations during the post-trainings.
Okay, so the next study that we reviewed was personal and social norms for food portion sizes in lean and obese adults. So first we're going to talk about the norms. The study states that norms are a belief about what constitutes usual behavior in a given situation and is thought to influence how people habitually behave. In this study, there are 2 specific norms that they focused on. First is personal norms, and social norms. Personal norms are the amount of food a person considers to be a normal amount for themselves to eat in any given situation. So social norms are the amount of food a person believes other people consider as normal in any given situation. The purpose of this study was to determine the effects of BMI, body mass index group, considered the gender, level of dietary restraint, and the level of food liking on personal and social norms, the relationship between the norms and how certain people are about them. The results showed that obese individuals were found to have significant larger personal norms for portion size compared to lean group, but there was no difference between social norms. These obese individuals also had significant larger personal norms than lean individuals. It wasn't seen in lean individuals. Men had significantly larger personal norms and smaller social norms compared with women, and they also had significantly larger norms compared with social norms. But for women, there was no significantly difference between the norms. For those with higher dietary restraint, personal norms were significantly smaller compared with those with larger restraint. And then those with larger restraint had significantly larger personal norms than those with social norms. The last study that we reviewed was Seeing More and Eating Less, the effects of portion size granularity on the perception and regulation of food consumption. The purpose of, first we talk about the portion size granularity. The study defined this as holding portion size constant while describing portions in fine grains. They also stated that if consumption If consumption judgments are indeed driven by external cues or portion size, as previous research suggests, then perhaps changing the granularity of portion size description rather than the portion size itself may be another route to shift to consumption judgments. In this study, they talked about fine grain labels and gross grain labels. So fine grain labels are several smaller units, for example, stating that 16 gummies equals 1 serving size, and portions in gross grain labels is simply stating that it's just 1 serving size. The purpose of this study was to test whether a small change, such as reframing portion size units, can influence food consumption by influencing people's consumption intentions. The results of this study was that there was a robust and reliable effect of portion size granularity labels on consumption intentions and food consumption simply. The use of fine grain labels decreases consumption intentions across all 6 studies. The process operates by shifting the perceptions of the size of food whereby portions described with fine grain labels are perceived to be bigger than portions described as within the gross grain labels. For example, 9 pieces of candy versus 1 serving. The study also found that granularity facilitates self-regulation of consumption, particularly when self-regulation would be most beneficial. The purpose of our study is to evaluate the use of a stimulus equivalence paradigm to teach graduate level students to make accurate portion size estimation. It also addresses critical medical needs. It was designed to improve health outcomes such as obesity and being overweight.
Methods. The participants in our replication were 4 females in the Midwest region of the United States, ages 23 to 28. The study took place in each participant's home. The following materials were needed: an electronic digital kitchen scale, 5 different dry foods. The participants used Cheerios, rice, popped popcorn, cereal, and noodles, Ziploc bags, measuring cups that were a 1/4 cup, 1/2 cup, 1 cup, and 2 cups, 4 identical plates, 4 identical clear cups, and portion size measurement aids. Portion size measurement aids are visual representations of a serving size, such as measuring cups, a baseball, or a computer mouse. The behavior and focus is accuracy of portion size estimations. Accuracy of portion size estimations is defined as the estimation of weight in grams within 20% of the target measurement weight. Examples include measuring on a tiered digital kitchen scale. Non-examples include measuring in pounds and measuring with a bathroom scale. The design of the study was a non-concurrent multiple baseline design in which each participant engaged in either 5, 6, 7, or 8 baseline sessions. For every other phase, the number of sessions completed were the same for each participant. The first step in data collection was to collect the gender, age in years, BMI, and weight status of every participant. In the second step of the study, each participant completed a pre-baseline procedure to determine the target measurement weight of Cheerios, cereal other than Cheerios, and any type of dry noodles. The target measurement of Cheerios was used in baseline, post-treatment, and maintenance conditions. The target measurements of both cereal and noodles were used in the extension condition. To find the target measurement weight of these 3 items, each participant weighed a 1/2 cup of the item 10 times, and then averaged the 10 measurements to determine the target measurement. After determining the target measurement weight, baseline data was collected. Baseline consisted of estimating a 1/2 cup of Cheerios without any measurement aids 5 times per session, with a total number of sessions predetermined by what baseline the participant was assigned to. Each estimation was weighed in grams after all 5 trials were measured. The results were then recorded. For each session, the 5 trials were averaged and the percent deviation was calculated. The training phase consisted of 6 sections: Training in each section continued until the participant responded correctly for 90% or more of trials, or did not respond correctly on at least 90% of trials after 5 presentations of the same section. Each presentation had 10 trials. In each trial, the participant set up 4 predetermined stimuli and the training assistant provided the item to be matched. The training assistant followed a checklist to ensure the training portion was the same across all participants and sections. The participant selected which stimuli out of the 4 was equivalent to the given stimulus. After the participant made a selection, she would check the measurement labels under the item given in the item she picked, and a plus or minus was recorded on the data sheet. The measurement used for the 4 stimuli in the item presented were a quarter cup, half cup, 1 cup, and 2 cups. Section 1 was matching plates of food to cups of food. Section 2 was matching cups of food to plates of food. Section 3 was matching cups of food to portion size measurement aids. Section 4 was matching portion size measurement aids to cups of food. Section 5 was matching plates of food to portion size measurement aids. And Section 6 was matching portion size measurement aids to plates of food. A post-training phase followed training. For this phase, the participants were once again asked to estimate a half cup of Cheerios without any use of aids. The participants weighed the 5 trials in each session at the end of the session to avoid any additional learning from occurring. The average and percent deviation were calculated for each session. A maintenance phase occurred a week after post-training. In this phase, the participants were once again asked to estimate a half cup of Cheerios without any use of aids. The participants weighed the 5 trials in each session at the end of the session as before to avoid additional learning. The average and percent deviation were also calculated for each session. The extension phase followed maintenance. Participants estimated a half cup of noodles and a half cup of cereal without the use of measurement aids. The participants weighed the 5 trials in each session at the end to avoid additional learning. The average and percent deviations were calculated for each session. Inter-observer agreement was collected across all phases of the study. A picture was taken of 2 trials during each session during baseline. During post-training, maintenance, and extension, a picture was taken of 3 trials during each session. The pictures were of the number on the scale and were shared with another participant in the study. During the training phase, a video was taken of 3 trials during each session. The videos consisted of showing the labels under the matching items. The videos were also shared with the same participant in the study as before. IOA was collected using the exact agreement method on a trial-by-trial basis. If the IOA fell below 80%, retraining on how to read a scale would occur, as well as retraining the training assistants on how to correctly follow the training checklist. The training checklist consisted of steps for the assistant to follow during the training phase. A portion of the checklist is provided.
Here is my graph. The average of my baseline with Cheerios is 12.5. The range is from 10.5 to 19.1. The average of my post-training is 0.7, range from 12.9 to 16. And the average of my maintenance phase is 2.7, range from 13.3 to 15.8. And the average of my extension number 1 and 2 is 7.9, range from 18.4 to 58.3. As you see that there's a great variability shown in the baseline phase, and the data points are farther away from the 0% deviation solid line. Once the training started, the data become more stable in level and trend. The data met the target estimation positive and negative 20% deviation dashed lines. I think this intervention is effective for me, and the graph shows a great improvement after the baseline phase. And I'm now able to estimate portion size more accurately.
The averages and ranges for my graph are as follows. For baseline, I had negative 8.7, and range would be negative 17.4 to negative 4.3. For post-training, my average was negative 2.4, and range was negative 13.7 to 5.3. For maintenance, my average was negative 9.23, and range was from negative 13 to negative 5.4. For the extension phase, my average was 6.35, and the range was from negative 9.3 to 20.9. Overall, my data was stable and between baseline and maintenance. During extension, there was a slight increase in percent deviation from the target. I concluded that the intervention was not effective for me. In all phases, my data point stayed within the acceptable limits, which was 20 and negative 20. Although in the extension phase, I did reach 20.9.
The data from my results are as follows. During the baseline phase with Cheerios, the average was 5.7 and the range was negative 1.4 to 20. During post-training phase, I averaged negative 8.3 and ranged from negative 15.7 to 1.4. During maintenance, the average was negative 2.6 with a range of negative 4.3 to 1.4. During the extension phase with noodles and cereal, the average was negative 0.2 with a range of negative 2.8 to 4.0. During baseline and post-training, data was more variable. During maintenance and extension, data was more stable and was more accurate, showing that it is closer to the zero, so there was less variability in each measurement. I can conclude that this treatment was effective for me because baseline was more variable, and while post-training was more variable, maintenance and extensions showed improvements.
The average of my baseline was 24.1 with a range of 7.4 to 53.2. For post-training, the average was negative 4.3 with a range of negative 19.1 to 7.4. For maintenance, the average was negative 2.8 with a range of negative 10.9 to 7.0. And for extension, the average was 2.5 with a range of negative 6.7 to 10.8. The variability of my data decreased from baseline session to post-training and beyond. The data points in the baseline phase were at a higher level than the post-training, maintenance, and extension phases. Because of the decrease in variability and level, the intervention was effective for me. And here is a copy of our group results showing the non-concurrent multiple baseline design of this study. The training results show that participants only required one presentation of each section, meaning they met the 90% or above criteria to move on to the next section. The average percent of correct responses are also included. The range of IOA was from 94.4 to 100% when looking at both pairs of participants. Because IOA never went below 80% for any phase, retraining was never required.
In conclusion, we can conclude that post-training showed less variation for some participants. We concluded that there is a functional relationship for participant 1 and participant 4 because their data in baseline was more variable, and after the training, there was less variability and their data was more stable. We did find, however, that portion estimation did not generalize to extension. Extension showed greater variability. We also concluded that our study showed low external validity because it did not reproduce similar results under different conditions, such as using different foods and possibly different settings, since we were all in different locations. The limitations of this study were, one, we all used different scales. So while we were all using kitchen scales, there is no way to determine that each person's scale was accurate and calibrated correctly. Another limitation is we did not conduct the study in a research or clinical setting. So each person conducted this in their own home with different trainers. While each trainer had a treatment fidelity checklist to follow along with, there is no way to guarantee that each trainer was implementing the checklist accurately. Going off of this with setting accuracy, there is no way to control for accuracy. There's no way to determine if each person waited until all 5 measurements were completed before weighing them on the scale. So we do not know if there was a learning curve for any participants. And we also do not know if they added food to the scale. Each person used different foods for training and extensions. While they were similar, they also varied. So some people may have been more familiar previously with certain foods. During extensions, one thing that was noted is there could be greater variability because people have more experience measuring out cooked noodles versus dry noodles, thus making it harder to estimate the portion of a dry noodle. Another limitation of our study is we only had 4 participants. Additionally, a limitation is only a half cup of familiar foods were used. So it could be deemed that participants showed less variability than those in the original study because participants were already familiar with what a half cup of food should look like, or they were familiar with the half cup of the certain foods that were chose for the study, meaning that we had a background previously in portion control, where participants in the original study did not appear to have such a background in portion control. In conclusion, here are our references from our literature review. Thank you for listening to our study, and we hope you have a good day. Are there any questions?
You guys do a really good job on this.
Thank you.
Thank you.
I think it's thorough. I think your presentation is spot on. I think one limitation that I would just throw out there for you guys to consider is the telehealth version of your IOA.
Okay.
So that because I mean, in essence, some of your other limitations actually capture that because it wasn't like a procedure that someone could observe all steps of. But I do think that you guys doing this project via video conferencing could also potentially be a limitation to the project. So I would just include that in kind of your write-up, or in the future keep that in mind. But you guys do a very, very good job. Your graphs are impressive. The only addition that I would add to your graphs is that early data point to signify what it is that you're measuring. But otherwise, it looks great.
Thank you.
Thank you.
Thank you.
Thanks.